Okay. Welcome and good morning, everyone. Thanks for joining. At xyzt.ai, we build a powerful analytics platform for mobility and traffic data. We work with road authorities, transport agencies, and cities across Europe and even beyond. So today's session will be about 20 to 30 minutes. We will leave some time for questions at the end. So if you have any, please post them in the chat. We will make sure to reply as much as we can. If not, then we will definitely get back to you in the following days with an answer to your question. So the title of the webinar says Designing Effective Floating Car Data Analytics Projects. And we want to explain why we chose the word designing. Because we genuinely believe that the outcome of a project is determined long before a single line of code is written or a single GPS record is loaded. My name is Nick. I am the Chief Commercial at xyzt.ai, and I'll be presenting today with my colleague Bart, who is founder and CTO. So before jumping into this, to the different topics of the webinar, Bart will first tell us a bit more about coffee beans.
Thank you, Nick, and thank you all for joining. So yes, I want to start with something many of us can relate to, that not all coffee tastes the same. And even so, if you use the same beans, and they can be great beans, if you brew it wrong, it will be wasted effort. And the same applies to data. You can buy the best data on the market, but if you analyze it wrong, it is a lot of wasted effort. And as we all know, data can be very expensive. So we don't want to do that. And we will guide you with this webinar to make sure that you're not wasting your beans. So yes, we are xyzt.ai. We are a software analytics platform that is used mainly with floating car data, but also with other temporal data, and it's indeed used throughout the world by government agencies, but also by engineering companies and agencies and so on. And our platform is being used in many projects. It's also been used sometimes not in projects, and we've learned a lot from all those different projects. We see what works, what doesn't work, and today we want to give you the lessons learned. So that being said, here on the right side, you see a small screenshot of part of our platform, but I'll give some more examples later. In essence, what we try to do, and that's really our mission, is to make it as easy as possible for analysts to get insights out of floating vehicle data. So just by connecting the data, immediately being able to analyze the data, and then, of course, to extract insights and share them with the different stakeholders. So that being said, Nick, I think you will go over the agenda today.
Yes, thank you, Bart. Thank you for this first introduction to our platform. So here is an overview of what we will cover today. So first of all, we will start with a grounded picture of what floating car data analytics can actually deliver. We know that there is a lot of hype in this space, and part of our job is also to be honest about what the technology can do, but also what it cannot do. After that, we will look at the patterns that we see in the projects that struggle. So it's not to be critical, but it's because recognizing these patterns is also how you can avoid them. We will also spend some time on what we think is the most underrated problem, use cases that are not properly specified before the works begin. And we have a good story that illustrates this in a way you will never forget it. After all of that, we will flip to the positive, and we will give you some insights in a well-designed project and how it should look like. And we will close off with giving you a practical playbook that you can apply immediately. So please stick around till the end, and we will tell you how to get the full downloadable version.
Thank you, Nick. So let's start with floating car data analytics. What can it deliver? And I'm trying to stay quite high level here because it's quite broad what you can do with floating car data to analyze traffic and mobility. First of all, floating car data is used for traffic monitoring, congestion detection in real time, in monitoring systems in traffic control rooms throughout the world. And it tells you where, when, how severe, how long is congestion, for instance, on the road. Um, Travel time measurement is something you can do very reliably with floating car data, including not only how the travel time is now, but also how it changes during the day. Is it different during peak hour than during lunch? And also, what's the distribution of travel times along a certain route? Origin destination flows, and we'll get back to that later. So origin destination analyzes where does traffic come from, where does it go to? Do people come from far away when they come to an event, or do they come from nearby villages? Those types of analysis can all be done with OD. Network performance benchmarking. This is really looking at the network and the capacity. Can it handle the flow of traffic across certain corridors over time, maybe in certain situations? That's an important use case as well for floating car data. And then a use case where our platform is used a lot, it's really in doing before-after analysis. So for instance, when a policy changes, for instance, in a city, there's a low emission zone being installed, or there's a change in the traffic speeds, or there's a change in infrastructure. What's the impact? How does it change the traffic? Is it better? Is it worse? That's something that can be done very well with historical data and current data. And then, of course, we all use Waze or other routing apps in the car, but maybe the transportation agencies, they don't like the routes that we take because they go to quiet neighborhoods. They don't take the main roads. So route choice analysis is something you can do really, really well with floating car data. So these are some of the high-level use cases that can be solved with floating car data. But keep in mind, floating car data is always a sample of the real traffic. It is not capturing every single vehicle on the roads. It's not counting every single vehicle. We see penetration rates, and that means how many vehicles are captured, between 5 and 30% by the best data providers. So this is something you have to keep in mind when designing your project, that you can't talk about absolute traffic numbers when you only work with floating car data. It's only a slice of the full traffic. What you can do is you can take relative computations. For instance, if you have a certain road, you can look at how it was yesterday compared to today and what the increase is or decrease is, for instance, in the median speed or in the number of vehicles, but you cannot give an absolute number there. And then also one thing that is important to realize when you design your project is that floating car data has a non-uniform coverage. And there's many reasons to that. One of the reasons that is easy to relate to is when you go on a long trip, for instance, on a holiday to the south of Europe, you use your navigation app because you're in an area that you don't know. But when you have a local ride to, for instance, the shopping mall or the neighboring city, many of us don't use a navigation app. And so not always the same coverage is on the different roads. And so typically on highways, you would see a much higher coverage than on the smaller secondary roads. So these are some of the implications that floating car data is just a sample and it's not capturing the full data. Then another dimension to take into account when you design your projects is that not all flavors of floating car data on the market are the same. We like to categorize the different types of data on the market in three different levels. From the left, the most powerful, to the right, the least flexible. And there's an important implication to the type of analytics that you can do with the different types of data. And let me start with the most powerful. and that's on the left. And that's really the raw GPS data. So if a car is moving and the car manufacturer or the navigation app is measuring the location of the car, for instance, every second, every 5 seconds, together with the speed, the heading, and then if you add the metadata, which is like the type of vehicle, you have very, very rich information on all those vehicles that are being captured. On the other hand, it's a lot of data, so it's really challenging to analyze this data. Luckily, that's really where we built XYZT.ai for. And this is really the most powerful data on the market. It is very granular and it allows you to do almost all the analytics that you can imagine. You can analyze the speed at different times of day, at different locations, travel times, delays. You can do density analysis, like which roads see the most traffic, which see less. You can detect congestion. You can analyze flows, where does traffic come from, but also which routes are taken. You can even see spatially, and we have customers doing that, how congestion builds up, for instance, near an exit on a highway. After how many meters does it start building up? And I'll show you later that with other types of floating vehicle data, this type of analysis will not be possible. And then finally, sublane behavior. Is something that is now very commonly done with this raw GPS data by the road authorities using our platform. Imagine you have a highway with 5 lanes. On the right side, you have the slow traffic with the trucks, and on the left side, you have the fast moving vehicles. For instance, in Germany, sometimes driving 200 kilometers an hour. You don't want to necessarily mix those two flows of traffic. And with the GPS data, you can statistically see and analyze those different lanes of traffic. So this is the raw GPS data, most powerful. Second type of floating car data we see on the market is what is often called trips data. We in the platform call it movement path data. Others call it trips data, floating vehicle trips data. And this is where you map match the GPS points, the GPS traces of the vehicles to the road network, but you keep the flow information. So basically, for every trip, for every vehicle, you have a sequence of road segments followed. And that's indicated in the little schematic figure here. So you still have individual trips. You just don't have the individual GPS coordinates anymore. Very much similar to the GPS data, you can analyze speed, travel time, traffic density. You can do congestion detection. You can do flow analysis like origin destination. You can see where traffic comes from and goes to. But you lose the ability to really see very granularly where does the congestion build up. And the main reason is that those road segments, they are typically 50 meters, 100 meters, sometimes 200 meters long. And you don't really see across that segment how the speed, for instance, differs. So that's why those last two use cases with the GPS data are not possible. The sublane behavior is obvious because every road segment is just represented as one segment. So you don't have the information on the sublanes in this data. And now moving to the right, we get to the least flexible, and that's what we would call pre-aggregated statistics. So that's really where you take a road segment and you have the average speed, the median speed, the 85 percentile speed, the number of vehicles captured over time, every 15 minutes, every hour. So this allows you to do the first four types of analysis, so speed, travel time, density, congestion detection, but you lose the ability to do the flow analytics. There are data providers that sell pre-computed OD, and that, of course, allows you to do some OD traffic flow analysis, but often the areas between which you can see the travel flow, they are predefined by the data provider. So keep this in mind when you design a project, that not every floating car data is the same. So from least powerful from most powerful on the left to least flexible on the right. To give you some visual view of what that looks like, this is the raw GPS data. On the left side, you see a density map of 2 weeks of data where traffic flows. So when it's dark, it's less traffic. When it's very bright, there's a lot of traffic. On the right, you would see the speed color-coded over those 2 weeks of data. And you would see really statistically along the road, you would be able to really see very fine-grained how the speed varies over the locations. This is a screenshot of the second type of data. So this is trips path data or movement path data or trips data on the market. This is, for instance, a selected link analysis that is computed on the fly on, in this case, about 10,500 trips of vehicles. So it's not pre-computed, it's really computed on the fly. And this is the final flavor. This is data from TomTom. We call it traffic stats data. It's still quite powerful to do all types of analysis. The only thing is you don't have the flow information. You don't really know how many vehicles took a certain turn or traveled a certain path. And all those types of data, of course, can be handled in our platform. So I think with that, Nick, we're up for our first poll question.
Yes, thank you, Bart, for explaining the different types of floating vehicle data. So first poll question for today. What do you primarily use or plan to use floating vehicle data analytics for? We have 5 options. A, travel time and speed monitoring. B, congestion analysis. C, origin destination insights. D, project impact or before after analysis. Or E, other. So we will give everybody a couple of seconds to answer, and then after the poll, we will also share the results. Okay, so here is the result. It's actually all of those. So it's a bit scattered. So everybody uses it, which is good, but for different reasons. So more or less every option has the same percentage. So thank you for replying to this first poll question. I will hand over to Bart again, who will tell us a story about a tank.
Yes, thanks, Nick. So I will tell you a true story without shaming anyone. But I was at a hackathon once of the army, and the hackathon was about requirements and tendering. And they gave the story, and it's still sticky for me. So I think it will be sticky for you as well. So they ordered a tank, made a very detailed procurement, very detailed requirements. In the end, the tender was won, and the tank fulfilled all the requirements that were written down. So that was all perfect. On the other hand, they couldn't use the tank at all, mainly because it couldn't fit a driver. You had to be 1 meter 70 tall, except the average soldier in that army was 1 meter 80. So the requirements were all very detailed in the armor, in the capacity of the tank, but not in fitting the driver, which is sort of essential when you have a tank. And this is something we see again and again in projects, in analytics projects, that even though it looks like the requirements are very detailed, some essential information is missing. And I will give you 3 examples, but Nick will give you really the strategy to overcome this situation. And I will go you in the problems and the examples of the bad cases first, but then we will flip to the positive later. So the first example is about GDPR, so privacy, data protection, which is in Europe, of course, very important, but also in the US is very important and in other regions. And so if you think about origin destination analysis, this is something that we see a lot in projects being defined. On the other hand, what we don't really see is, okay, what is the real use case? the people say in tenders and in projects, we need to be able to do OD analysis. But is it like for local analysis or is it for cross-country analysis? That is typically not defined. And if you know a little bit about the data that data providers sell on the market, many of them, they have to segment the trip of a vehicle in smaller subsegments, basically because of privacy protection. So in many data providers, you see trips segmented in 20 minutes, sometimes it's 2 hours. Some of the trips are full length from start to end. It all depends on the source of the data. So if you end up in the case where you get 20-minute segments, you won't be able to do an analysis across Germany, for instance. So OD will be fundamentally broken. And this is a case we actually have seen in projects before. Second case also about data is that be aware that if you buy data, data will be delivered in all types of flavors. Some will give you access to a big data storage in the cloud. Some will give you through an FTP, very old school. And some of you will give you access through an API. Now, if you know that in many projects we see billions and billions of data points every day being provided, if you then have to go through an API to query that data, it is not usable. So it means that you cannot really get, even for a baseline analysis, you don't get data out of the API. And of course, there are rate limits, there are limits on the API number of queries that you can do. Even worse, we've even seen data vendors selling data, but in fact, it's not really data, it's a platform. So you need to access the data through a platform, but it's all locked inside the platform. And we know from experience that people working with floating vehicle data, they really like to also have their hands on the files and be able to use this data in all types of solutions, products, workflows, data science, and so on and so forth. So keep that in mind. Another example of that, just specifying the data is not enough. You also have to specify how to be able to access it, where it will be stored, who will store it, and so on and so forth. And that brings me also to the last one, which is a storage cost. If you think about floating car data, and many of the data vendors, they know that they have very special contracts with the cloud providers because it's so much data. And we've seen a tender, for instance, that asked for 7 years of historical floating car data on all the road segments in the region. If you think about that, 7 years is a long period. And is that really useful? In this case, the data amounted to about 250 terabytes of storage. And even just buying a fast disk or a fast number of disks that can store this is expensive, let alone storing this in the cloud, backing it up, and making it accessible for the entire contract period, which can be 1 year, 2 year, but sometimes up to 6, 7 years. It's a big cost in the cloud. So keep that in mind. So is it really necessary to have 7 years of data? If, for instance, the COVID years are there, do you really need the COVID years? Traffic is entirely different afterwards. And also, if you go back until 2019, you lose the opportunity to source data from the newer data providers that have really good quality data with a lot of parameters and a lot of information in there. So again, it's sort of a hidden requirement, but it's something that is lost in the many project definitions that we've seen. And I think I spent a lot of time on the negative. Nick, you have the solution for this, I think. But before that, let's go into the second poll question.
Thanks, Bart. So, poll question 2, before we indeed go into the positive, how would you describe your experience with floating vehicle data analytics? A, we use it regularly. B, we have used it in a few projects. C, we are exploring it. Or D, no hands-on experience yet. So we will give everybody a couple of seconds again to reply, and then we will again share the results of the poll. Okay, so here are the results of the poll. So let's say that a fourth of you, 25% uses the data regularly. Another 25% uses in a few projects. And then there is also part of you that has no real hands-on experience yet. So we hope with the webinar to be able to give you everything you need to use the data in your next project. This brings me to three questions, which should make everything a bit more practical. So from everything that we described, so the data layers, the common challenges, the examples, there are actually three questions that every FCD analytics project needs to answer. Preferably not at some point during the project, but actually upfront. Ideally, even before you start your procurement. So the first one is, what decision are we trying to support? It's not the data that we want, but it's what is the action that we want to get out of it. So if you can't answer that question, then you're not ready to launch your project. Second one, what type of mobility and what spatial scope? For example, as Bart explained before, do we want to make OD matrices based on long distance, or is it more a local effect within your city that you want to analyze? Are you looking at all the roads or only at major corridors? Is your project focused on urban congestion, or is it really cross-border flows? And getting these things wrong early can be expensive to fix, because if you don't have the answer to this question, then you will probably source the wrong data, because you will either not have enough data or way too much, and it will either way cost you a lot of money. Then the third question is, what are actually the constraints? There are privacy rules. You have obviously a fixed budget for your project, the existing systems, what are the capabilities of your team, and all of these shouldn't be blockers. They're actually about designing the inputs. The earlier that you know, the better that you can design around. So if you manage to answer these three questions very clearly and very specifically, then we'd say you're ready to start your project. If you can't, then we would really encourage you to don't start it yet, but spend another week on the specifications, and it will really save you time afterwards. So that brings us to sharing how a well-designed project should look like. So first of all, it obviously starts with the decision, but it doesn't start with the data. And that is something that we see a lot in the projects where we are involved in, is that they first think about what data do we need, and then afterwards they design the use case. And in our opinion, it should be the other way around. So you should first design the use case. What do I really want to get an answer to? And then look at what data is available to get it. Then second one, validating the data characteristics upfront. So before any procurement decision is made, somebody should ask, can this data actually answer our question? And that relates back to the first one, when thinking about which data do I need to make the right decision. Then the third one, Bart spent a lot of time on explaining, that is the right aggregation. So to be clear again, it's not about good and bad. It's about what type of aggregation do I need, again, to be able to reply the use case. So it's something that sounds very simple, but it actually requires some discipline, because the temptation is always, I want to get everything. And that is also something that we unfortunately see a lot in tenders. Bart also gave the example of 7 years of historical data. Typically, everybody wants to get all the data, but do you really need it? So raw data gives you the maximum flexibility. but it comes at a cost, and typically the cost is higher. And sometimes the pre-aggregated data is just what you need, so it's sufficient for your use case. Then the fourth one is about performance. So Bart also mentioned about how the terabytes can add up if you look at sourcing multiple years of data, and the infrastructure, you need to make sure that the infrastructure is sized for the actual query load. So someone should have thought about what a typical analyst session looks like and what is the response time that is acceptable. It cannot be the idea either that you do a query and then you need to wait for a couple of hours before getting the results. And then the fifth one is about flexibility. So we spend a lot of time, and especially Bart and his team spend a lot of time in the ability of onboarding your own data as well. That can be sensor data, it can be incident logs or planning data sets, and being able to combine those with floating car data, that is enorm valuable. So solutions that lock you into a single vendor's data and interface, they make that impossible. And it's actually, maybe again, it can be sufficient for your use case, but in general, we see that it's not. And it's really important to have the flexibility to combine different data sources within one single project. Then the last one is all about the design and how it evolves. So the questions that you are probably trying to answer today will not be the same as the ones that you will need to answer in 3 years. So you should really look for a platform that scales with you, a platform that can grow as well in the capacity of the data that it can handle, but also in the analytics that it can perform. So overall, we believe that the success of a floating car data analytics project is determined long before the first data set arrives. And it's not about pessimism, it's just a simple invitation for you to invest in the right things early. That brings me to a third poll question for today. Are you interested in finding out more? And here we only have 2 answers. A, yes, please contact me. And B, not for now, but please keep me updated. We will again give you a couple of seconds so that everybody can reply to the question. Okay, thank you very much. Before going to our playbook and the Q&A session, we also want to look a bit into the future. So where is this heading? And we see 3 big topics there that we would like to bring to your attention today. One is the real-time and historical data, they are converging. So traditionally, there were separate workflows for this. You had teams that were looking at live dashboards on one side, and then you had another team that was looking at the historical studies on the other. So what we now see is that more and more there is this requirement of having one single source of truth, so one platform that can handle both. And that will actually enable you to monitor live traffic and instantly also compare it to historical patterns without needing to switch tools. Then the second one is, of course, the AI-assisted analytics. We all know that AI is hot, and probably a lot of you use AI agents on a daily basis to assist in their work, and that is actually what we did or what we do as well. So in the XYZ.ai platform, we also have a natural language query capability. So you can literally ask questions like, show me all the trucks leaving the A1 conjunction towards the A45, passing through Ludenscheid, but not ending there, and that's for only weekdays and mornings. And the platform then will generate the correct spatial temporal route filter and applies it to the billions of GPS records that are available. And so to really ensure you, it's not some kind of demo feature. It is something that is actually in production today and is used by multiple of our customers. Then the third one is an open ecosystem, and that might maybe sound a bit weird, but we believe that the value of your floating car data investment compounds every time you connect a new data source. So every time you answer a new question, every time you involve the platform to meet new needs. And so closed systems, they don't compound. So we believe there is really a value in not only sharing the outcome or sharing the insights, but also in sharing and combining the data that comes in. So the organization that invests in the right foundations now, they will probably be the ones that will extract maximum value from the floating car data in the next years. That brings me to our playbook. So we are turning around these questions into a downloadable playbook. So it will be a very hands-on PDF checklist that you can use in your own project, share with your colleagues, or include in your briefs. And you can get it by scanning the QR code on next slide. So before ending the webinar, please, if you want to download the playbook, scan the QR codes on the slides. Then there is also our contact info. So if you have a very specific project or you want to see the XYZ platform in action, then reach out to Bart or to myself, and we'd be very happy to organize a live demo with real floating car data. Now, before ending this webinar, we also promised some time for Q&A, and I have seen in the chat that there are some questions. So before ending the webinar, Bart, if you're okay with it, I will launch some questions to you.
Go ahead, Nick.
Okay. One question, which is, and I think it's an interesting one as well. What is the best approach to show a detailed event data across a city? It often becomes overwhelming and it's difficult to see the patterns through the chaos.
True. So yeah, if you look at floating car data, for instance, event data can be like harsh braking or cornering, like dangerous maneuvers that drivers do. And if you plot everything on a map, it becomes scattered and it becomes difficult to analyze. What we really suggest is to combine this data with, for instance, neighborhood information or maybe crossing information. So you can combine like two layers of data. And in our platform, you can basically join those two layers of data and get a ranking, for instance. You get a ranking, for instance, for every neighborhood or for every crossing, which sees the most events or the most dangerous events. And that is much more digestible. So then you get like tables or charts that are clearly ranked from worst to best. And that really gives you insights. So we have many customers that, for instance, build dashboards on this type of data. And they also not only plot it on maps and in charts, but they also use just tabular views on the worst to the best, for instance. And that's quite easy to set up. So that's my suggestion there. That being said, of course, seeing the density map, for instance, is also very informative. And also there we have some filtering capabilities that you can really focus on the hotspots. So that is also possible. And then finally, if you connect with an agent, you could let the agent start querying and figuring out what's the most problematic area, for instance.
Okay, thank you, Bart. Then I also see that Julian raised his hand. So if we can allow Julian to speak, then Julian, please You can ask your question to Bart directly.
I
But
see Julian is muted, maybe.
yeah, I also see that Julian is muted, so I don't know if we can unmute him.
I can't do it.
Okay. Julian doesn't seem to come through. Maybe Julian, maybe if you want to ask your question in the chat, then we can come back to it later. There is another question as well, Bart, that we got also up front of the webinar. What types of temporal and spatial data can be analyzed using movement path data?
Okay.
I think you
So,
talked a bit
yeah.
about it, so
Yes. So, in our platform, we categorize the type of data in 5 categories. For instance, one category is just static data. It's the simplest. It's a typical GIS data. One type of data is movement data. That's the GPS, the raw GPS data. And then we have movement path data. That is that second type of FCD data that I put on the slide, going from most powerful to least flexible. So it's trips. And with the trips, you can do basically any analysis in the XYZT platform. You can do flow analysis, you can do route analysis, you can set from to filters, you can do trend analysis, you can do density analysis. That being said, compared to the point data, the sublane and the buildup of traffic on road segments that are long in the data, that is not possible with that type of data. But all the other stuff like true filters, selected link, very advanced route filters, like you mentioned, it's all supported. Yeah.
okay. Thank you very much. Then I see that we also have a question from João da Costa. So, Bart, what data sources does your platform use the FCD data for? Could you specify which providers you currently support, Inrix, TomTom, here, others, and whether it's possible to integrate our own data very easily? I think I even can reply to that, but go ahead.
Yeah, yeah, very, very relevant question. The answer is very positive. At this moment in time, we have customers using data from all possible floating car data providers. So the ones that you mentioned, like Inrix, TomTom here, but there's many more, are used in our platform, in all flavors. So from the raw GPS data all the way to the traffic stats data. And that being said, you have to see our platform really as an open platform. So it's like, if you're familiar with Power BI or Tableau, it is a platform that is meant to be used with your data. So it is set up to make it very easy to upload your own data. Basically, you can drag and drop a sample file from your data. It detects what's in the data, and then you do some further configuration on which of the properties you want to use. And once you're ready with that, you can validate your data, and then you can push your gigabytes or terabytes of data to the platform. You can do that also by dropping on a web browser, but you can also use an API, and everything can be scripted. So we see a lot of people using cron jobs, for instance, every night or every 5 minutes or every minute, to push data to the platform. So we have some partners in the data space, but we basically partner with everyone that has good quality data. So we can also guide you, Joe.
Okay. Thank you, Bart. We have two more questions. I think we are going a
Okay.
tiny bit over time, but let's go. One question from Neil. What data sources can be used in developing nations in Africa and Asia, focusing on rural area, if any, of course?
Okay. Yeah, very interesting question. Our platform is being used, for instance, in Africa, not yet with floating car data, but with sensor data and counting data. So that data for sure is readily available by the traffic agencies and the mobility uh, analysts. Um, that being said, we also see a lot of data from routing applications. So most likely there could be floating car data as well in those areas. So very happy to explore, I think, and Nick, what the possibilities are if there's a concrete need or project.
Definitely.
Yeah.
Okay, thank you. Then there is one more, but I can cover it, I think. So the question is, do you cover the Middle East regions in your data analytics platform? So here, again, very positive answer. Yes, we do. So by default, our platform is cloud-based, so you can access this from anywhere, everywhere. We do know as well that in the Middle East there is often the requirement to have the software running within the country or even on very specific instances. For that, to accommodate that, we also developed an on-premise deployment. So if that need is there, then no worries, we can do that as well. We actually today have some customers in the Middle East already. So happy to talk about your use case and your needs, and I'm sure that we will definitely find a solution to that as well. Um, that brings me to the end. We still have Julian's question, but Julian, I would encourage you to drop me or Bart an email, and we'd be happy to reply to your question as well. Apart from that, thank you very much, all of you, for attending our webinar, and we hope to see you again soon.
Thank you all. Bye bye.
Bye.